Welcome back to Syntax Grid. Today we're diving into the world of supervised versus unsupervised learning and exploring how they apply in real-world scenarios. So, let's get started. Supervised learning. Supervised learning is a type of machine learning where the model is trained on a labeled dataset, meaning each input has a corresponding correct output. The goal is to learn the mapping from inputs to outputs. Key objective: to make predictions based on past data. Learns from input-output pairs. Example: email, spam or not spam. Categories of supervised learning. 1. Classification. Output is categorical, discrete labels. Examples: spam detection, disease diagnosis, yes or no. Image classification, cat or dog. 2. Regression. Output is continuous, real numbers. Examples: predicting house prices, stock market forecasting, temperature prediction. Common supervised algorithms. Linear regression, logistic regression, k-nearest neighbors, EANNN. Support vector machine, SSEM. Decision trees, random forest, naive Bayes. Gradient boosting, ACSG boost, light GBM. Use cases: any scenario where historical labeled data is available and the task is to predict future outcomes or classify new observations. Unsupervised learning. Unsupervised learning deals with unlabeled data. The goal is to find patterns, groupings, or structures within the data. Categories of unsupervised learning. 1. Clustering. Grouping similar data points. Examples: customer segmentation, document grouping, image clustering. 2. Dimensionality reduction. Reducing the number of features while retaining important information. Examples: PCA for visualization, feature compression for model training, noise removal. Unsupervised common algorithms. K-means clustering, hierarchical clustering, DBA-scan, PCA, principal component analysis, TSNE. Autoencoders in deep learning. Use cases: when you want to explore your data, discover insights, reduce dimensionality, or group similar data points without having labeled outcomes. Instead of definitions, let's talk through each scenario naturally. Supervised versus unsupervised. Real-life scenario comparisons. 1. Spam email detection. Supervised learning. Application: spam detection. Algorithm: logistic regression, naive Bayes. Why this learning type? We have labeled examples, spam or not spam, allowing the model to learn from known categories. Goal: predict whether a new email is spam or not. Unsupervised learning. Application: email grouping. Algorithm: k-means, hierarchical clustering. Why this learning type? No labels exist. We want to explore hidden structures or group similar emails. Goal: automatically cluster emails by topic. 2. Stock or finance. Supervised learning. Application: stock price prediction. Algorithm: linear regression or LSTM. Why this learning type? Time series data is labeled with actual prices at each time step, ideal for forecasting. Goal: predict future stock values. Unsupervised learning. Application: market crash or unusual pattern. Algorithm: isolation forest or DB-scan. Why this learning type? Rare events like crashes aren't always labeled. Anomaly detection helps identify them based on deviation. Goal: detect sudden or rare financial events. 3. Customers. Supervised learning. Application: purchase or churn prediction. Algorithm: decision tree or random forest. Why this learning type? Past behavior is labeled. Example: whether customer purchased or left, making it trainable. Goal: predict who will buy or churn. Unsupervised learning. Application: customer segmentation. Algorithm: k-means or Gaussian mixture model. Why this learning type? No predefined customer types. Clustering helps find natural groupings in data. Goal: Automatically cluster emails by topic. 4. Images. Supervised learning. Application. Object classification. Algorithm. CNN or AVM. Why this learning type? Large labeled datasets exist. Example, cat, car, person. Which models can learn from? Goal. Identify objects in new images. Unsupervised learning. Application. Image compression. Algorithm. PCA or TSNE or autoencoders. Why this learning type? Images are high-dimensional. Dimensionality reduction helps in feature extraction or visualization without needing labels. Goal. Compress or visualize image data. 5. Banking or security. Supervised learning. Application. Fraud prediction. Algorithm. Logistic regression or XGBoost. Why this learning type? Historical fraud data is labeled, enabling models to learn fraud patterns. Goal. Classify transactions as fraud or not. Unsupervised learning. Application. Anomaly detection. Algorithm. One-class AVM. Isolation forest. Why this learning type? Fraud is rare and evolving. Unsupervised models catch unusual patterns not seen before. Goal. Flag suspicious or rare transactions. Thanks for watching. We just explored 5 real-world scenarios that show the difference between supervised and unsupervised learning. If you missed our previous video where we covered supervised learning in detail, make sure to check that out, links in the description. Don't forget to subscribe.